All right, so we have just a little bit left in 3.1. We were looking at other bases and turning numbers from other bases into our base and from our base 10 into other bases. And in particular, we had gotten to the very end where we are attempting to turn one of our numbers into a base number in a different system. So the one that we're on is 11,028, and we're turning it into base 4. So let me remind you, anytime we turn our number into another base, what we're doing is we're doing this division scaffolding like we did, find one of them, over here. All right, so what we need to know is we need to know the powers in that base, whatever that base system is, whether it's just base 4 like we're about to do now or whether it's Mayan, okay? It's the same thing. We just need to know the powers of that base. So since we're working in base 4, the powers are going to be 4s. So we're going to have, and I'm just going to write them from left to right. I'm sorry, I'll do it from right to left like I normally do. So we have the 1s place. We would have the 4s place. 4 squared, 4 cubed, 4 to the 4th. And they would keep going up. And we kind of need to know what these numbers are to know when to stop. So 4 squared, of course, is 16. What's 4 cubed? It's 60, 64 is right, yeah. About 4 to the 4th. Just take 64 times 4 with a calculator that you all have with you, I know. What's 64 times 4? 256. That sounds good. All right, we're going to have 4 to the 5th. So again, you can get there by just taking 256 now times 4. 1,024. And then we've got 4 to the 6th. 4,000, what was it? 96. We're getting close. Let's try one more just so we can double check to make sure we don't need it. I don't think we do. 4 to the 7th. So what is 4,096 times 4 one more time? Should be 16,384. Awesome, and that's too big, right? So this one's too large. These are numbers 11,000. So these are the numbers that we're going to be using in our division scaffolding, okay? And a 4 and a 1 here at the end. I didn't write them down because we weren't doing any simplification. So we start with the largest value on the outside of our division. And that value here is 4,096. And we're dividing our 11,028 like this. So how many times will 4,096 go into 11,028? 2 times. And what is 2 times 4,096? 8,192, and we'll subtract. So what do we get when we subtract that? What is 11,028 minus 8,192? About 2836. Does that sound good? Sure. Okay. We're going straight down the list of powers. So the next power is the 1024 placeholder. That clearly goes in there at least once, but it'll go in twice again. What is 2 times 1024? 2048 or 2048. So if we subtract, what do we get? 788 sounds good. So my next power after 1024 is 256. So how many times will 256 go into 788? And what is 3 times 256? Yeah, this time the numbers are really close together. The subtraction is just 20. It's really tempting to skip over the places, but we can't do that. We will write down the 64, even though 64 will not go into 20. What it ends up looking like is a 0 over here. Right, 64 goes into 20 0 times. 0 times 64 is 0. So when we subtract, we still have a 20. My next place value down from 64 is 16. So that one actually goes in how many times? Once. And then 20 minus 16 is going to give me 4. My next place value is 4. 4 goes into 4 one time. Just because we're at 0, like there's no remainder here, does not mean we're done. We're only done when we get the 0 remainder and we have divided by 1. And clearly, there's nothing left, so it's a 0. But I don't want to forget that piece or I'm off one of my place values. So the cool thing about this division scaffolding is that your answer's right here. All right, from the top down. So we're just going to write them. I have 2, 2, 3, 0. 1, 1, 0. And I'm in base 4, so I'll put subscript with the word 4. I'll make a bigger deal about this in a moment, but I want to look back at the last ones that we did the last time, the last two, and then this one. What I'd like for you to notice is that I get a value that, for all intents and purposes, without the subscript, looks bigger than what I started with. Right? So the smaller base gives me a seemingly longer number. My larger base 10, that's my original number, gave me a number that had 5 digits. My base 4 gave me a number that had 6 digits. That's what we should be seeing happening. So if you see it happen, we did it over here too, right? So we had base 12 and it was 3 digits, and then we put it into base 10, it was 4 digits. Smaller base, no more digits, or at least look at bigger looking kind of number. Wow, base 2, it's killer. 4 digits long, but it's only 1 digit in base 10, right? Base 10, bigger base, smaller digits, smaller number of digits. Okay, we have one last one to do. 99,999 into base 9. So we need powers of 9. Okay, so we have the ones place, and then we have the nines place, and then we have 9 squared, and 9 cubed, 9 to the 4th. Let's find out what some of these are. 9 squared, y'all know, it's 81. What is 9 cubed, or 81 times 9? 729. And if I do it multiplication by 9 one more time, I get 6,561. And we'll do it one more time to make sure. Times 9 one more time.
59,049.
Now, technically, I'm still smaller than my 99,999, but it's clearly not necessary for me to go one more step. I don't need to double check that. I should be able to see that one right away. Because if I try to divide my 9,999 by the place value that I got right there, that was 59,000, what is it, 49? It's only going in one time. So I'm sufficiently large on my bases. It does only go in one time, so I have 41, it's 49, sorry, 59,049. That's what I get when I multiply by that 1. What do I get when I subtract that? 40,950. And I'll go down the line. So I did this one, now I'm going to do 6561. How many times will 6,561 go into 40,950? 6 times is right. And 6 times 6,561? 39,366. Did I hear you right?
Yes.
Okay. And what is that when subtracted? Okay. My next place value is the 729. So how many times will 729 go into 1584? Twice. 2 times 729 is... Okay, good. Subtract again. 126, does that look right? What's the next number I'm going to divide by? 81. How many times will 81 go into 126? Once. And when I subtract, I have 45. I'll divide by 9. It actually goes in exactly 5 times, leaving me once again with no remainder, but I have that one additional step to divide by 1 at the end. I always have that last step. There's nothing left for it to go into, so it goes in 0 times. And my solution is all along this line over here. So I have 1, 6, 2, 1, 5, 0, and this one is base 9. Now, it's the same number of digits. I started out with a 5-digit number, and this is a 5-digit number. But do you see how this still looks? Isn't that right? Did I get them all? Okay, yeah. Do you see how this still looks the same way as before? I end up with a bigger number corresponding to a smaller value. No, I have 6 digits. I was like, something's wrong. I have 6 digits. Oh my goodness, can't count. I started with 5 and I ended with 6. There we go. So I do have what ends up looking like a bigger number. What I wanted to make attention to, but I don't have an example that shows it, is I might have the same number of digits, like that's a possibility, but the numbers will still look larger. Like maybe I still have 5 digits on both of the 2 sets of numbers, but one of them looks a lot like 90,000 something, and one of them looks a lot like 65,000 something, right? So the number still looks like it's a smaller or a larger number, even though it has the same number of digits. But most often the digit number itself changes when I restructure it. All right, I think I have a couple more things I wanted to show you, just as some fun things at the end. We didn't really talk a lot about like where do you see Roman numerals occurring. This is actually a T-shirt that I saw when I was in Kohl's one day, and I thought, hey, cool, here's a T-shirt with a Roman numeral on it, so I took a picture. But where do you see Roman numerals occurring in real life? Because that's one that we may not see Mayan and Babylonian and all those, but we see Roman numerals. Where do you see Roman numerals, Monica? Super Bowl. So some sporting events will use them. Yeah. What else? In books. Sometimes people will use them in books as the chapter numbers. Names. Actually, I was just thinking about that one, and we don't usually mention that one. So if somebody who's like they're the 3rd or the 4th, you'll see Roman numerals for those. Yeah. Sometimes on the copyrights of movies. So sometimes we'll use them. What you'll see them with is dates as well. So when my brother-in-law, many moons ago, so like 16 years ago, was getting married, he was getting married in the Washington, D.C. area. Very historical. And a lot of the like buildings, the old buildings, or a lot of the old churches actually have the cemeteries in the churchyard, but the cemetery stones or the buildings themselves will have dates on them, and the dates will be written in Roman numerals. So we do see them out and about at different places. So they're something that we see used still quite a bit.